resistor is the most used passive circuit element in the circuit design, and in fact it is hard to imagine any circuit without the resistors. So in this video, let us find out briefly about these resistors and let us see different characteristics or the different parameters related to these resistors. And then let us see the different types of resistors which are used commercially. Now as we know, this resistor is the passive circuit element which opposes the flow of current or electricity, and symbolically it can be represented by these symbols. Now the property of this resistor to oppose the flow of current is known as the resistance, and it is defined by the unit of ohm. Now for the given resistor, if 1 volt of voltage is applied across that resistor and if 1 ampere current is flowing through that resistor, then we can say that the resistance of that resistor is 1 ohm. Now this resistor is the linear element. It means that as we increase or decrease the voltage that is applied to this resistor, the current that is flowing through this resistor will also increase or decrease, and the slope of this VI characteristic defines the resistance. Now the relationship between the voltage, current and this resistance is defined by this Ohm's law. So now let us see the different parameters which affect the resistance of the resistor. So for any resistor, the resistance can be given by this expression. So as you can see over here, it is directly proportional to the resistivity of the material. So if we change the material, then the resistivity of that material will also change, and accordingly the resistance of that material will also change. Then this resistance is directly proportional to the length of the resistor, and it is inversely proportional to the cross-sectional area of this resistor. So as we increase the length of this resistor, then the electrons which contributes in the flow of current will see the more resistance. Similarly, if we increase the cross-sectional area of the resistance, then these electrons can move easily across the resistor. So if we increase the cross-sectional area, then the resistance of the resistor will reduce. So in this way, by changing these three parameters, we can change the resistance of the resistor. Now these resistors are available in various sizes and shapes. But before we see the different types of resistors, let us see the different parameters or the different characteristic of the resistor which we should consider before selecting particular resistor for particular application. So here is the list of different characteristic or different parameters of the resistor. So let us see them one by one. So the first factor is the power rating of the resistor, and it defines the maximum power which can be handled by the resistor. Now the power which is going to get dissipated across the resistor can be given by the simple expression of P is equal to V into I. So if 5 volt of voltage is applied to the resistor and if 1 ampere of current is flowing through that resistor, then we can say that the power that is going to get dissipated across the resistor will be equal to 5 watt. So the power rating of that resistor should be more than the 5 watt. Now as a general rule of thumb, the resistor which we are going to use should have a power rating at least 2 to 4 times the maximum power which is going to get dissipated across that resistor. Now the commercially available resistors have a power rating of as low as 1/16 watt or as high as 300 watt. Now apart from this power rating, sometimes the manufacturers also provides the power derating curve. So this curve basically defines with temperature how the maximum power which is going to get dissipated across the resistor will change. So while selecting particular resistor, apart from the power rating, one should also need to take care of the ambient temperature of the resistor. Now the second parameter of this resistor is the tolerance. So basically this tolerance defines the deviation of the resistance from the nominal value. So let's say if you have one resistor of 100 ohm with a tolerance of 1%, it means that the value of the resistance will be in between the 101 ohm and the 99 ohm. Now the commercially available resistors have a tolerance value of as low as 0.1% up to the 20%, and it is also even possible to achieve the lower tolerance than the 0.1%. Then the third parameter associated with this resistor is the temperature coefficient of the resistor. So basically it defines the amount by which the resistance value changes with the temperature. Now this temperature coefficient can be either positive or negative, and generally it is defined by the unit of ppm per degree centigrade. So let's say we have one resistor of 100 ohm and it is operated at 25 degree centigrade, and the temperature coefficient of the resistance for that resistor is 50 ppm per degree centigrade. Now suppose if this resistor is operated at 29 degree centigrade, then the value of the resistance R will be equal to 100.02 ohm. So basically here this 50 ppm will get multiplied by the change in temperature along with the value of that resistor. So let's say for some resistor, if the value of this temperature coefficient of resistance is 500 ppm, in that case just by 4 degree change in the temperature, the value of the resistance will change by a 0.2 ohm. So this parameter is particularly critical when the resistor is operated at high temperature. So for any resistor, the value of this temperature coefficient of resistance should be as low as possible. Now the next parameter which is associated with this resistor is the frequency response of the resistor. Now generally we assume that the resistor which we are using is purely resistive in nature, but depending upon the construction of this resistor, it also has some inductance and the capacitance, and because of that the maximum frequency at which this resistor can be operated will be limited. So while selecting a resistor for high frequency application, one should also need to consider this parameter. Now apart from these parameters, the other parameters related to this resistor are the stability and the noise. So this stability defines how stable the resistance value will remain over the period of time. So basically it defines the stability of the resistor. Now every resistor generates its own noise. So while selecting a resistor for low noise applications, one should also need to take care of this parameter. So these are the different parameters which one should need to take care of while selecting the resistor. So now let us see the different types of resistors which are used commercially. So these resistors can be classified in two categories. The one is the fixed resistors and the second is the variable resistors. The fixed resistor means that once the resistor is fabricated, one cannot change the value of that resistor. While in case of a variable resistor, the value of that resistor can be changed by changing the knob. So now let us see the different types of fixed resistors which are used commercially. So the first type of resistor is the carbon composition resistor. So this resistor is made up of carbon particles and the binder like a clay. So this type of resistors are used in applications where you are dealing with the high energy pulses. But nowadays these type of resistors are not used because of its poor temperature coefficient and poor stability. Apart from that, this type of resistors also produce more noise and they are also less accurate. So this type of resistors have been replaced by the film type of resistors. So the first type of film resistor is the carbon film resistor. So if you see the internal structure of this carbon film resistor, then you will find that on the ceramic substrate, the thin layer of this carbon film has been deposited, and this film has been deposited in the form of helix. So just by changing the pitch of this helix, one can change the resistance value of this carbon film resistor. Now this type of resistors are a low cost resistors and they produce a less noise compared to the carbon composition resistor, and the tolerance value of this resistor is also less than the carbon composition resistors. So this type of resistors are used in a high voltage and high temperature applications, and also these type of resistors are available in a wide range of values. So the next type of film resistor is the metal film resistor. So in terms of the construction, these resistors are very similar to the carbon film resistor, but here instead of carbon film, the thin layer of metal film has been deposited on a ceramic substrate. So these type of resistors are also low cost resistors, and in terms of the noise and tolerance, they are better than the carbon composition resistors. Apart from that, in terms of the stability and the temperature coefficient resistance, they are quite good, and generally they are preferred for the high frequency applications. Then the next type of film resistor is the metal oxide film resistor. So in terms of the construction, they are quite similar to the metal film and the carbon film resistors. But here, instead of metal or carbon, the metal oxide film is deposited on the ceramic substrate, and generally the tin oxide is used as a metal oxide layer. Now this type of resistor is also low cost resistor, and in terms of the stability, noise and the tolerance, the performance of this metal oxide film resistor is poor than the metal film resistors. But if you compare in terms of the carbon composition resistor, then they are much better. Also in terms of the temperature coefficient of resistance, these resistors are poor than the metal film resistors. But this type of resistors are particularly used in high temperature and high surge applications. Then the next type of resistor which is used quite frequently is the wire wound resistors. Now if you see the internal structure of this wire wound resistor, then the metallic resistive wire is wound around the ceramic material. So the thickness or the gauge of the metallic wire decides the resistance of this wire wound resistor. And generally the metal alloys like copper alloy and the silver alloys are used for this resistive wire. Now this type of resistor provides you very high accuracy, and also they have a very low temperature coefficient of resistance, and because of that they are quite suitable for high precision applications as well as for the high power applications. But these type of resistors are not suitable for high frequency applications. So these are the different types of axial lead type of resistors which are used commercially. Apart from that, you might have observed tiny resistors in various PCBs and various motherboards. So these tiny little resistors are known as the surface mount resistors. Now if you see the internal structure of the surface mount resistor, then you will find that on the ceramic body the thin layer of resistive film has been deposited. Now generally metal film or the metal oxide film is used as a resistive element for this surface mount resistor, and on top of this resistive film the thin layer of insulating layer has been deposited. Now on the both sides of this surface mount resistor you will find the metallic contacts, so that this SMD resistor can be soldered on the PCB. Now as the surface mount resistors are made up of metallic film or the metal oxide film, it is possible to achieve a very high accuracy and very low tolerance value. So these are the different types of fixed resistors which are used in commercial applications. Apart from that, the various types of variable resistors are also used in many applications. So in these resistors, just by changing the knob, it is possible to change the value of the resistance. So this is all about the different types of resistors which are used commercially. So in the next video, we will find out how to decode the value of the resistor just by looking at the code which is written on the resistor, or just by looking at the color codes which is printed on the resistor. So that's it for this video. I hope in this video you understood the different types of resistors which are used commercially, as well as the different parameters which needs to be considered while selecting a resistor for particular application. So if you have any question or suggestion, do let me know in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.